Okay, I'm going to do the assessment. I'll do part A. This is looking at the energy of a bouncing ball. How is that affected by mass? So a dependent variable is energy loss, or the rebound height, and the independent variable is mass. To do this, we can set up a table similar to what was in our booklet. This is in our energy booklet. I'm just going to highlight this table, the headings, and put it into Excel. So just highlight them, just go copy. It's 1, 2, 3, 4, 5, 6, 7. So open Excel and go across 1, 2, 3, 4, 5, 6, 7 and Control V or paste, and our headings are placed in there. Now the investigating factor in part A is mass, so we can change that to mass. And let's actually make up some masses. So let's say you measured it to be, the first one was, let's say it was 20 grams. Now we put it in kilograms, so grams we've got to divide by 1,000 to get to kilograms, so 20 divided by 1,000. You could actually put it in like this. You could say equals 20 divided by 1, 2, 3 divided by 1,000. So it's 0.02, or you could do it in your calculator separately and then type it into Excel. Let's say the next one was 30 grams. So 30 divided by 1,000, we're putting it into do that one again, into kilograms. This one is, let's say it's 40 grams. Now it's in kilograms. This one here we'll do 50 grams, and now it's in kilograms. Now the initial height of the ball, that's the the height we release it from. Let's say we always dropped it from a 1 meter high height, 1 meter. Now the initial energy, potential energy, is given by mgh. Now m is the mass of the ball, so we go equals the mass. Now the mass, we're going to use this mass over here, so I click on it and it says it's cell A3. I do shift 8 to do a times. I've got a times by g. Now g is gravity, which is 9.8, and then go times h, and the h is this initial height there, and press enter. Now what we can do is just go to the bottom right and drag that down holding the left key, and it will automatically do that formula for every one. So if you look at the formula at the top, it's A3, now it's A4, now it's A5, now it's A6. It's using these values here on the left to create these values here on the right, using the formula once and dragging it down. Now the final height of the ball, let's make up some values. Let's say it rebounded to, the first one rebounded to 50 centimeters. So we'll put 50, but we need it in meters, so divide by 100. And we want to actually put that as a number, so we put equals 50 divided by 100. This one here, let's say it goes to 55, so it's 55 divided by 100. This one here, say it was 60, equals 60 divided by 100. And this one here was 61, equals 61 divided 100. Now if we want to know the final energy, we've got to use mgh again. So we go equals, we use the mass, which is this, m times 9.8 for g, times h. Now this time we're using the final energy, so we're going to use the final height. So I click on that one to use that height. Press enter. Click in there, go to the bottom right until it turns to a black crosshair, and then drag down. That's all the final energy. Now we want the loss of energy. To get the loss of energy, it's going to be the initial energy minus the final energy. The initial energy will be more because it's higher than the final energy, which is lower. So to do the loss, we're going to do equals, and we do C3, that one, minus the final E3. Enter and drag that down. And so they're the losses of energies for all the different masses. Now the loss as a percentage, we need to divide it by the initial and times by 100. So go equals, and we do the loss of energy divided by, which is that symbol, the initial, which is 0.196. So I click in the cell, and then my times by 100 to get it to a percent. Press enter. Click in the box bottom right, drag down, and so there are percentages, losses of energies. Now to graph this, we're going to highlight the two columns. So if I highlight this one, hold the control key down and then highlight that one, I go up to insert, click on this graph here and the top left one, and it puts a graph like that. Now we can position that anywhere on the spreadsheet, and I'll just zoom out. So we have here our trend. On the bottom is our mass, and we can add these things in. We can click on the plus. We can put in axis titles, so click on that one, and I can type into there what that represents, and that was our energy loss. Down the bottom we had mass. This is our investigating factor, mass. And of course chart title, you can put your own in there, just say energy loss versus mass. Now we want a trend line, so you click on the plus and go down to trend line. Now that's actually moving down. Now for us to analyze this graph, we can see as the mass gets bigger, the energy loss gets smaller. Now if you want the best bouncing, then you want the minimum loss of energy. So because this is energy loss is going down, that means it's getting better bouncing characteristics. So as the mass goes up, the bouncing characteristics are getting better. That's what that graph is saying. Your results may say something else, so I just made these up. Okay, now we have to put that into a Word document. So what you can do is just simply highlight that whole table and go copy, and you open Word and paste it into your Word document. So you could just click in here and go paste. There are different options. You can choose whether you keep all the formulas, etc. You can choose any of those. Same with the graph. If you go back to Excel, I can click into the Excel and go copy, and then back to Word, and then paste by Control V, or go up and say paste. It's best to go wrap text and put it in front or something, and that way we can drag that graph around onto the Word document. Now you are to write up your report, you need to follow these criteria. Hypothesis is the aim, what you expect to find. So in this case we could say as the mass gets better, we expect it to bounce better. The variables, the dependent variable, that was our rebound height or the energy loss. The independent variable was the mass, that's what we were controlling. We were keeping constant, the variables keeping constant was things like the height which we released it from, the temperature of the ball, etc. And where we measured it from. The method, tell me exactly what you did. So tell me that where you measured the ball. Did you measure it from the bottom, the middle, or the top? How did you measure it? What did you use? Did you use a slow motion camera, etc.? Results is what we just did. These two things are called results, the table and the graph. And the discussion is analysing that graph, what I just quickly mentioned before. Application is applying it to the real world. So here we found that as the mass got heavier, that the bouncing improved. So we could say as it rains in a football field, the mass of the ball will get heavier and therefore it will bounce better. That sounds a bit stupid. That's because I've set this down the wrong way. Yours probably might go up the other way. And we've also got questions to answer, and the questions are sitting in the actual assignment sheet. So if you go back to here, you can see the question here, and to answer that it says if the rain increases the ball up to 100 grams, use your graph to try and predict what would happen. To do that you have to extend the graph. So at the moment we're only at, this one here is in kilograms, that is 50 grams, and we have to go out to 100 grams. We need to extend that. To do that you could go back into Excel and try and extend that graph out. One way is you could actually make up 100 grams. You can put here equals 100, we need to convert to kilograms divided by 1000. That's taking it out to 100, and we could just extend this graph. When you click on the graph it highlights these two columns. So if you click on the bottom of that mass and drag it to include that point, it'll now change the scale to include that 100 grams. And so we can read off that dotted line that 100 gram corresponds to approximately 20% energy loss if we read across to the y-axis. Now in real life we don't expect trends to continue on like that, and that's one of the limitations of science experiments. It's actually extending results in the lab too far, so you get a point where it becomes absolutely absurd.